so much.
Absolutely.
Great. Thank you. Thank you, everyone. Is everyone comfortable? Let's start. Let's go for it. So today we're going to talk, and this is the title of my talk, Brain Meets Computer. So we're introducing the brain to computers. If I was seated on that side, my question was, what are you doing there? What am I doing here? I want to show you a future where the human brain is connected to computers. Short intro. I'm a scientist, visiting scholar at the University of California, Berkeley, in the United States at the Center for Science, Technology, Medicine, and Society, at the Program for Medical Humanities. It's not just about science. If you want to make a difference in the world, you have to bring the technologies to the market. And that's where the entrepreneurial part comes in. I created a couple of companies. And also a philanthropist. We all live in a planet where we're blessed to have this quality of life, but many billion don't. And I think it's our responsibility to improve their lives. I'm the president of a nonprofit that invested so far more than $100 million in biomedical research. So that's why I identify as a philanthropist. Question for today. How do we connect to the cloud today? How do we access the internet? Well, we pick up a cell phone, we have our thoughts, and we have a question. Let's say the question is, what is brain bar? So this gentleman in his head has this question, what is brain bar? So he sends through his spinal cord an electrical signal, moves through his arm, reaches his fingers, and he types on the cell phone, what is brain bar? On Google. The cell phone sends an information to the cloud, and the cloud replies saying brain bar is today the best conference in the world. Certainly. I was very impressed with the conference, by the way. Really amazing. And then the information is displayed on the cell phone. He looks, his eyes read the information on the cell phone, and the information goes from his eyes to the visual cortex and then through the rest of his brain. And now he knows that brain bar is an amazing conference. So idea, electrical impulses, reaches the cell phone, connects to the cloud, comes to the cell phone, goes through your eyes to your brain. Next question. Can we do this directly? Can we connect the brain with the cloud without having to use a device? Can we do this directly? That's the question. In 2019, 3 years ago, we published a paper titled Human Brain Cloud Interface. The paper was published on the journal Frontiers of Neuroscience. It's a very respected journal in the neuroscience field. And what was interesting about this was that the paper got a lot of attention from the scientific community. So scientists around the world said, this is very interesting. They said, this makes sense. This is the time to make this a reality. How do we know they think this? Because the paper is now on the top 10 most viewed papers ever among 10,000 papers, more than 10,000. So the journal has more than 10,000 published papers, and this paper, the paper we published, is now on the top 10 most viewed papers ever, with more than 200,000 views. Well, but more importantly than being proud of the success of the paper is the fact that this means that the scientific community recognizes that this is the time to make this technology a reality. Let's look into science and technology. What is our body made of? Cells, right? Cells. But what are our cells made of? What I'm showing you here is happening right now inside many of your cells. This vesicle is being carried along a microtubule by this motor protein, a small nanorobot. It's literally a bio-nanorobot inside your cells. And it's not just the motor protein. Our cells are built with small nanomachines. This is a picture, the most precise picture today, the most precise representation of a cell today. So this is very small. It's inside our cells, small things moving around. Question: can engineers and scientists work at this scale? Can we move things in such a precise way? Let's check. 10 years ago, IBM created a movie, the smallest movie ever made, built with atoms, carbon atoms. These carbon atoms are extremely small. They're way smaller than the motor protein you just saw walking with the vesicle. And they did a small movie with it. Why did they do the movie? Just to illustrate and show how powerful our technology is today. I think the movie didn't go to the theaters, though, but still. Well, you could say, right, that's cool. We can move atoms. These atoms are really small, even smaller than the small things we have inside our cells. But can we build things? Can we pick up those atoms and build small machinery? Can we build something like a nanorobot? A small device that we build that's smaller than the motor protein you just show us. We can. These are nanocars. These nanocars are built today, and there's a competition to win a race with these nanocars. So essentially, scientists are playing video games. That's how we're spending the government's money. Let's go for the next one. Well, you could say, that's cool, but that's, how do you interface these man-built micro-robots and nanorobots? How do you interface this with biology? Can we interface this with our cells? What I'm showing you here is a sperm bot, a micro-robot picking up an individual sperm cell. It's helping the sperm cell gain mobility. It's moving the sperm cell, and what you're about to see is that it will fertilize an egg. This is how human life starts. This is how your life started. So let's stop here for a second. So scientists can build nanomachines. These nanomachines can interface with cells similarly to what we have inside our cells. So let's make the following assumption. We will build many of these nanomachines, and we'll use them to interface with neurons in our brains. Kind of scary. Let's assume that for a second. If we have that technology, could computers handle the information we have in our brain? When you buy a computer, what's the question you do when you go to a store? When you buy a computer, how much storage capability does the computer have? How many files can I put there, right? How many photos can I store on my computer? That's the storage capability. The second question you do to the salesman is, well, it's not just about storing, it's about using programs. So what's the processing power of the computer? Can I run Windows 2040, for example? Or AutoCAD, right? So that's the storage and the processing power of the computer. Question, what's the processing power of a human brain? 10 years ago, we published a paper where we quantified the processing power of a human brain. And the number is 10 to the 16 bits per second. Well, that's scientists' numbers. Let's explain this for everyone. 1,000 is 1 with 3 zeros. 1,000,000, 1 with 6 zeros. That's 10 to the 6. 1,000,000,000, 10 to the 9. So 9 zeros. We're getting there. 1 with 12 zeros, 10 to the 12. A trillion. 10 to the 15, a quadrillion. So the human brain has 50 quadrillion bits per second. What's the fastest supercomputer today? The fastest supercomputer is 10 to the 18 bits per second. 20 times faster than the human brain. Is it better? No. It's different. So we're not saying that supercomputers are better than human brains, but we're saying that supercomputers are capable of handling the data if we had a way to send information from our brains to the computers. So essentially, what we're saying is computers are capable of answering our thoughts and our questions in real time today. Faster than the human brain. So we have these machines, they interface with the brain, send information to a computer, no need for a cell phone anymore. But have we ever built a prototype? Does this really work? What I'm about to show you, this lady is controlling a robotic arm with her thoughts only. She's thinking, and she's able to feed herself. She's a tetraplegic. And how do we do that? We install, this is a different group from our group, but it's still at UC Berkeley. We install these small machines next to nerves. And what you're about to see here is the data that we receive on the computer. It's extremely, extremely biocompatible. We can install this next to the nerves, and it can stay there for decades. No problems. Very friendly to the human body. And the idea here is to show you that this is happening today. We're testing small prototypes that will allow us to interface nerve cells with computers. This gentleman is controlling a robotic arm for amputees with his thoughts only, just by thinking. Has other applications, can be used for other healthcare applications. And as I said, this is a reality today. I'm not showing you the future here, just showing you reality today as a prototype. Well, you could say, great, we're gonna build these things, but there's nobody in the world that we're gonna sell this, right? Who is crazy enough to decide to create a company that's gonna sell this, right? Let me introduce you to Mr. Elon Musk. He created recently a company called Neuralink, and their mission is to interface the human brain with computers. Well, that's Elon, right? I mean, just that's one person that we know. You know, he has some ideas. Is anybody else in the world trying to help or do this kind of thing? There are currently more than 188 neurotechnology companies literally spread all over the world. Let's assume this is going to happen. Let's say that in the next 10 to 15 years, this technology will be available. How will this make the world a better place? How will this make your life better? Let's go back to the paper. Let's think about education. One of the Millennium Goals is to provide every human being with education, access to education. But there are more than 1 billion people in the world living in the poorest areas of the world. Will we ever build a university there? It's not cost effective. So how can we give them access to high quality education? What if we had something like Starlink? Elon is creating something called the Starlink, and Microsoft is doing also, many other companies. They're ensuring that everywhere in the planet, we all have access to internet anywhere. If that happens, anywhere, even those living in the poorest areas of the world will have access to the internet. So if they had a connection with the cloud, they would be able to access information. And then the question is, how will this change education? Even in our country, in developed countries. Do we need to have the same concept? Do we need to feed people with information? Do we need to memorize things? Or, with this technology, can we focus on happiness, on values, and have teachers focus on helping students understanding how can they improve their lives? Because everything else is accessible just by thinking. So you don't need to memorize. How about intelligence? And this is a slightly more radical idea. We're all born with what we measure as our IQ. Einstein was a pretty smart individual. What if we had direct access to the cloud? In the cloud, we would have access to the AI algorithms. And just to tell you, recently, artificial intelligence was able to outperform a board of certified physicians diagnosing cancer. So if you had access to the cloud, you would be able to diagnose cancer better than a board of certified physicians today. How about virtual and augmented reality? No need for glasses. We can just display information in our field of view. And artificial intelligence was mentioned as an existential threat for humanity. Elon Musk said it, and if Elon says it, we need to hear it, right? And many others, not just Elon, many others, brilliant scientists around the world said, we have to be careful. We have to find a solution. AI is amazing, but it can be an existential threat. What if we had direct access from our brain to the cloud? There will be no AI in humans, because upgrading AI would be upgrading humans. Improving the AI algorithms, improving the quantity of information in the cloud, would obviously be improving our quality of life and improving our access to that information. So improving AI, so AI would not be an existential threat, it would be an augmenting technology. We're going to go for the Q&A if this sounds kind of weird. I want to hear your questions. So the conclusion of the paper we published was, it's indeed, well, currently, it's biologically impossible for us to keep up with scientific knowledge. A PhD student today, finishing his PhD thesis, is outdated 6 months after doing his PhD. So we cannot keep up with the quantity of information being created. This is amazing. It means that I'm extremely proud to be part of the human race. We are collectively creating a tremendous amount of knowledge and the better world. But how do we keep up with it? How can we individually follow up what's happening? So it's indeed important and urgent that we connect the human brain with the cloud. If you want to get in touch, let me know anytime. We're going to have a Q&A session. If you have any other questions, because it's so short, it's not a lot of time, feel free to get in touch with me via my website, for example. And I want to thank you. I know there's a lot of people from different places in the world. Obviously, I have to thank you in your own language. For Hungarian ones, thank you for welcoming me to your wonderful country. Köszönöm. Thank you.